notice, and this is the regular copyright. We continue with the mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, Number Theory and Computation. All 33 videos in that section have been published as of 14th of October 2024 on YouTube in their entirety. Right now, I am working on these 12 videos in Section 2, Consumer Arithmetic, and hopefully by October the 31st, 2024, I should have that completed. By November 2024, sets, December 2024, measurement. So by the end of the year, those 4 sections should be completed. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And May 2025, by mid-May, vectors and matrices. As I have pointed out before, Section 1 has been subdivided into 33 videos. That is to say, I have divided it into 33 videos. And all those 33 videos, as I pointed out before, have been published on YouTube in their entirety. Reminder again that this section, that is Section 1, forms the foundation on which the rest of the syllabus is based. So please look at these 33 videos from Section 1. Make sure you know them well if you intend to go on with the rest of the work. Reminder also that you need to know the times tables 2 to 12, since calculators are not allowed in paper 1. So Section 2, I have subdivided into 12 videos. We finished Objective 7, Video 7, that was the last one. Now we are at Objective 8, Video 8, that deals with appreciation and depreciation. Keep in mind that not all of these videos will be available on YouTube in their entirety. This one that we are doing now will be made available in its entirety, the full video. So we completed those 3 objectives from this section, and these 4, that would make a total of 7, completed and published on YouTube. Only 1 has not been published in its entirety. That's the one with Objective 5. Now we are at Objective 8, which says solve problems involving appreciation and depreciation. So let's begin with depreciation, since this is easier for most of us to understand. Well, what is depreciation? Consider for a moment that Mr. Haynes bought a new car for $40,000 5 years ago. He used it for those 5 years. There are some dents on it, and the odometer now shows 107,000 kilometers. A few parts are broken, but they have been fixed or replaced. Obviously, the value of the car has decreased. The loss of value of an item over time is called depreciation. One industry that uses this concept of depreciation is the car insurance business. You may insure your car for $40,000 one year, say when it's brand new, but the next year The car insurance company will depreciate that car by a fixed percentage, say 10%. So for the second year, its value is 40,000 less 10% or 90% of its original value, which will be 36,000, and so on. Now, there are two methods of calculating depreciation. One is called the straight line method, and this method is based on decreases by a fixed amount every year. That's a straight line method. And the other one is called the reducing balance method, and this is based on decreases based on a fixed percent, not a fixed amount every year. Now we will consider each one in some detail as they are fairly easy to understand and calculate since you are already familiar with the principles involved here. So let's begin with the straight line method. Mr. Jones bought a new car for $40,000. It is expected to last for 15 years, after which its scrap value will be $3,000. You are to calculate its annual depreciation using the straight line method and then find its value at the end of 6 years. The annual depreciation will be the original value minus the scrap value divided by the life expectancy. So it originally cost $40,000. Its scrap value is $3,000 after 15 years. So in the 15 years, you would have used up $37,000 of its worth over 15 years. So you divide that 37,000 by 15, you will get $2,466.67. That is how much its value decreases every year. Now, what will its value be after 6 years? That is after the first 6 years. So you take the original value, which is 40,000, and you subtract from that its annual depreciation, which is this amount, multiplied by the 6 years. So the annual depreciation multiplied by 6 years. And when you work that out, you get $25,199.98. $25,200. So that is what its value will be at the end of the 6th year. Now, in the event that there is someone who did not quite understand what was just done, let's go it over again in some details. Let's deal with the annual depreciation. The original value is 40,000. The scrap or disposable value is 3,000. So its loss in value will be 40,000 minus 3,000, $37,000. But that is over 15 years. Now, that loss of value is distributed evenly, that's why we call it straight line, over 15 years. So that if you divide the 37,000 by 15 years, you will get its depreciation every year. That's for part one. Let's go into this using a table this time. So the car is valued at $40,000. Its depreciation that we calculated is $2,466.67 per year. So at the end of the first year, it would depreciate by this amount and its value would become this. So it is 40,000 minus that and you get this. The second year, it will depreciate by this. Remember, we said straight line. So we will subtract from 37,000, we will subtract that, and we will get this for the end of the second year, and so on. All right, so this is the straight line depreciation method. Every year, it is the same amount that it depreciates by. Straight line method, the value decreases by a fixed amount. A fixed amount. Notice also by the year 6, the value is 25,200, which is what we calculated when we were using the formula. But this now is using a table going through each depreciation period. Depending on what you are asked to do in an exam, you may have to go through the table like we did here, or you could use the formula. So the value after 6 years will be the original value minus the annual depreciation times the number of years. 40,000 minus this annual depreciation times 6, and 25,200 will be its value at the end of 6 years. Now, I hope that is clear. For CXC, you may only be asked to show the first few rows of this table. Maybe they will ask you for 3 or 4 or 5 years, but they wouldn't ask you for 15 years. Again, if you could do the first few rows of this table for, let's say, 4 years, then obviously you can continue that method for 15 years. Still on depreciation, using the straight line method, an engineering company bought an electric generator set for $135,000. It is expected to last for 20 years, after which its scrap value will be $8,000. You are to calculate its annual depreciation using the straight line method and its value at the end of 10 years. So this followed the same steps as example 1. Annual depreciation will be the original value minus the scrap value divided by the life expectancy. So that would be 135,000 minus 8,000. And the answer you get from there, you divide by 20 years. And so each year, using the straight line method, this generator set will depreciate by $6,350. Now, after 10 years, what will its value be? You will take the annual depreciation multiplied by the number of years, and the answer you get from that, you will subtract from the original amount. So 135,000 minus 6,350 times 10. And when you work that out, its value at the end of 10 years will be $71,500. Now, I'm not teaching you accounts here or business, but you will have to know all of these if you are doing business or accounting. So just in case, again, there is someone who may have problem understanding what we just did, let's deal with the annual depreciation. The original price was $135,000. The scrap or disposable value is $8,000, which means that its loss in value is the original price minus the scrap value, which is $127,000. But that takes place over 20 years. If we are using the straight line method, we will divide this loss in value by 20 years and come up with $6,350 per year. So here is this same work done in Microsoft Excel. Present value, 135,000. This is our depreciation per year. You know how this works by now. First year, it depreciates by this. So if you subtract that from this, you will get this value. Next year, it depreciates by the same amount. So if you subtract this value from that one up there, you will now get this one and so on. We are going to 10 years, which is here, 10 years, $71,500, which is what we got when we did it the formula way. This table that you see here, you may or may not be asked to produce such a table in an exam, but if you see such a table, you should know how to interpret it. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. After all, it doesn't cost you anything, and that means a lot to me. We are still on depreciation. Now we are going to deal with reducing balance depreciation, and that uses a fixed percentage every year, not a fixed amount, a fixed percentage. So, example 3, let's go back to Mr. Jones. His new car is $40,000, and it is expected to last 15 years, after which its scrap value is $2,925.83. Calculate its value at the end of 5 years using the reducing balance method at an annual rate of 16%. Now, firstly, the scrap value here is irrelevant. This is just here to confuse you. We don't need the scrap value to work this, because remember, we are not using the straight line method. We are using the reducing balance method, which is based on a percentage every year. So what we will do, we will set up a table with a heading of year, depreciation, and present value. And then we will work that out for 5 years. So year, depreciation, present value, 16%, which is 0.16. Present value is 40,000. That's where we are starting off. Year 1, 2, 3, 4, and 5. In the first year, we will find 16% of that, and that will be our depreciation by the end of the first year. So by the end of the first year, the car will lose that value. So we subtract 6,400 from 40,000, and that will be the new value at the end of the first year, 33,600. Second year, we will again find 16% of this value here, which is now this. Notice it is less than what we had up here. So that has to do with the reducing balance, because the present value keeps reducing. And if you keep finding 16% of this present value here that keeps reducing, then obviously the depreciation will also reduce. So now you subtract that from this, and the present value at the end of the second year will be this. Keep doing that. 16% of that, put it here, subtract it from this, put your answer down here. At the end of the third year, the car values $23,708.16. 16% of that, put it down here, remove it from there, put that value here. And so by the end of the fourth year, the car has depreciated to $19,914.85. We still have one more year to go. 16% of this, 19,914, would give us this value. So by the end of the fifth year, it will depreciate by this much more. Subtract that from the present value at the end of year 4, and you get $16,728.48. Now, if we keep going, now the question did not ask for that. It just asked for 5 years. 5 years. This is the Microsoft Excel working out, $16,728.48. But you see, you wouldn't have a table like this if you're doing an exam for math. So this is just for your information that this can be done. You put in a formula and you copy the formula straight down, and eventually in 15 years, you find that it would reach its scrap value. Now let's go back to that engineering company and its generator set. It is expected to last for 20 years, at which point its scrap value will be $2,550.41. Calculate its value after 4 years using the reducing balance method at an annual depreciation rate of 18%. Now remember I told you this scrap value has no consideration in our calculation. Maybe for accounting, but not in this math class. So let's set up a table for 4 years. 18% present value is 135,000. Year 1, 2, 3, 4. At the end of the first year, its value will depreciate by 18%. So we find 18% of that, put it down here, which is $24,300. So that is how much its value will decrease by at the end of the first year. So at the end of the first year, it's now valued this amount. Then for the second year, we depreciate it by the same percentage, not same amount. So we find 18% of this number, put it down here, which is $19,926. Subtract it from that and put your answer here, which will now be its present value at the end of the second year. And you can keep doing that. 18% of that is this. Subtract it from that and put the answer down here. And then finally, you find 18% of this amount, put it down here. Subtract this depreciation for the fourth year from the present value at the end of the third year, and that will give you this number. So it is $61,036.44. Now we could have continued that, especially that we're using a table. In Excel, we just drag the formula down and we will find that in 20 years, it actually depreciates to this amount, which is the scrap value, $2,550.41. But you were not asked to do this table. But if you see a table like this, you should be able to understand what it means. Now, so far for depreciation. Now we will deal with appreciation. Turn our attention to appreciation. Well, this is not somebody praising you for the good job you did or rewarding you with a trophy. No, that's not that kind of appreciation. In business and its accounting, some items called fixed assets, like building, machinery, etc., they lose value over time. So that would be they depreciate in value. Conversely, there are other assets, example land, renovated buildings, collectibles, which increase in value over time. They are said to appreciate. The concept is the exact opposite of depreciation that we just learned about. So depreciation, something loses value over a period of time. Appreciation, something increases in value over a period of time. So what is appreciation again? In accounting, appreciation refers to an increase in the value of an asset over time. This increase can be due to factors such as inflation, market demand, or improvements to the asset. Generally, appreciation is measured in terms of money. While the calculation involved is not difficult, The concept of estimating or predicting future rate of increase is difficult, but that is not our problem. We will be given numbers to work with in this math class. We leave that for the economist. So we will consider two situations. Given the original cost and the rate of appreciation, find the future value. And secondly, given the original cost and the future estimated value, calculate the rate of appreciation. So let's begin with the first one. Given original cost and rate of appreciation, find future value. Mr. Haynes bought a piece of land for $150,000. If it appreciates at 5% per annum, what will be its value at the end of 6 years? Now, we will use the same principle we use for calculating compound interest, but on an annual basis. So you know this principle already. So the appreciation rate is 5%, which is 0.05. The current value is $150,000. So let's write down the years here. Year one, it will increase in value by 5% of the present value, the current value. And that is $7,500. If you add that 7,000 to this, you would put the answer down here. And so at the end of year one, this is its new value. For year two, we will find 5% of this new value, put it down here, which is $7,875. And then at the end of year two, it will now increase in value by this amount. So we will add this amount here to that, put your answer down here. So at the end of year two, this is its new value. I think you get the hang of this. Year three, it will appreciate by this amount, which is 5% of that. Add that and this and put your answer down here. Then for year four, it will appreciate by 5% of this amount. If you calculate that, you put it down here. You get this. Add it to this last value. So at the end of year four, it's now worth that amount. Year five, it appreciates, not depreciates, appreciates by 5%. So we find 5% of this, write it down here, add that appreciation to the last value, and at the end of year five, it is now worth $191,442.23. Lastly, we find the appreciation on this last value, and we get this added to the last value, and it is now worth $201,014.35. That is if you do it line by line, year by year, to show how the appreciation works. So your answer is this answer here that we got. So let's look at that same question again using this table for 6 years. If we go for 10 years, we go for 8 years, we go for 9 years, 10 years, 4 years. If you see a table like this, you should be able to interpret it. So the appreciation is 5%, that is 5%. Current value is 150,000. These numbers may change. You should be able to interpret this table. Now, there is a very simple formula to use to arrive at the values that we see here after a specified number of years. And we will now look at that formula. Rather than go through this table year by year, there is a formula that we can use. So we will do over this question here about Mr. Haynes and his $150,000 piece of land, 5% per annum for 6 years. So that was the table that we used. But now we will use a formula. FV is future value. CV is current value. So the future value is the current value times open bracket 1 plus appreciation as a decimal to the nth power, where n is the number of years. Now, you could see some similarity here when we were finding amount based on compound interest. It's basically the same formula. So the future value, 150,000, which is the current value, multiplied by 1 plus 0.05, that is our percentage based as a decimal, and 6 years. So you work that out, the factor here. When you work this part out, you get this, multiply that by 150,000, and you get $201,014.35, which is what we had here at the end of 6 years. So if you're not asked to show a table like what we have up here, you can use this formula. It's faster, easier, but sometimes you may actually be asked to show the table. Okay, that was for 6 years that we just did. So we came here, we got a 6-year value. Let's try for 3 years using the formula. Now we know 3 years we will get this value here, that. But let's use the formula. Future value is equal to current value times open bracket 1 plus appreciation as decimal, close bracket, to the nth power, where n is the number of years. So we substitute the numbers we are given, the values we are given. 0.5, which is 5%, 3 years. You work that out. This part, you will get this, multiply that by 150,000, and you come up with $173,643.75, which is exactly what we have here. Now let's try for 9 years. That is 9 years. Same formula. We should get $232,699.23. So future value is equal to current value multiplied by open bracket 1 plus appreciation as a decimal, close bracket, to the nth power, where n is the number of years. So 150,000.059 years. This part here works out to be this, multiply 150,000 by that factor, and you get $232,699.20 we got here when we use Microsoft Excel. So calculating the future value is fairly easy using a formula or using a table calculating each year individually. Now that is fairly easy. What is a little more difficult is if you are given the original cost and the future value, calculate the rate of appreciation. Mrs. Huxley bought a piece of land for $300,000. She wants it to appreciate to $500,000 in 7 years. Calculate the annual appreciation rate required for that to happen. All right, so the appreciation rate, and this formula may look kind of difficult, but it really isn't. What you do is you find the nth root of the future value divided by the current value, and once you get that, you minus 1 from it. N is the number of years. 7 years. So we find the seventh root of 500,000, which is the future value, divide by the current value, 300,000. And once you get that, you then subtract 1 from it. So this part in here works out to be 1.66667. You will find the seventh root of this, which is that, and then you subtract 1 from it, and you get this, which is 0.0757 as decimal equivalent. You carry that to percentage, you move the point 2 places to the right, and so you get 7.57%. So we are saying, based on this calculation, that in order for Mrs. Huxley to get $500,000 on her initial investment of $300,000 over 7 years, the appreciation rate must be 7.57%. Of course, if it were 5 years, you find the fifth root, and then you put in the future value over the current value. So this formula at first glance may look difficult. And I noticed that that was not given in the formula sheet. I will assume that if CXC requires you to use this formula, that they would give you the formula at the end of the question. So if we use that appreciation rate, put it in Excel at 300,000 current value, and we follow the pattern here, you would see that it will, in 7 years, it will become $500,000. That is, if we use Microsoft Excel. But you may not have Microsoft Excel to use. So you know what we will do? Let's reverse engineer this answer that we got, this 5.57%, to see if indeed her $300,000 would become $500,000 in 7 years at this rate of appreciation. So remember, she wanted to know what rate of appreciation she should get in order for her 300,000 to become 500,000 in 7 years. And we calculated and said it will be 7.57%. So let's rephrase that question now and use that 7.57% and see if that 300,000 will become 500,000. So future value, current value, multiplied by 1 plus appreciation as decimal to the nth power, where n is the number of years. We substitute the values we are given, 300,000, 0.0757 to the 7th year. We work that out. This part here becomes that, multiply that, 1.66666. Use that to multiply this 300,000. And yes, we get $499,987.83. So yes, Mrs. Huxley will reach her desired goal of 500,000 if she invested 300,000 for 7 years at 5.57%. Objective 2.8, solve problems involving appreciation and depreciation. And that should suffice for this objective. And that brings us to the end of objective 8 in section 2.